Okay, we're out on the docks. As I mentioned, the folks at Hargrave have been generous enough to allow us to come aboard the new 85 so we can have an overview of the cooling system. Brian Fowler from Pantropic Caterpillar is going to join us. So let's go see if we can find him and have a peek at what we're talking about today. Always easy to find him because Brian's right there on the boat ready for us. Good morning, Brian.
Hey, Paul.
How are you?
Good. How are
Mind
you?
if I come aboard?
Yeah, welcome aboard.
Nice to see you, buddy. Thank you
All
so
right.
much. Let's invite the audience aboard as well, and we'll have a peek at what we're talking about. Come on aboard. There you go. All right. So, Brian, before we jump inside, what I'd like to do is I'd like you to give me a moment of overview of what are we talking about with a cooling system in today's modern diesel engine.
Sure.
Actually, before you even do that, I got a better idea. I've already had COVID.
So have I.
So I think we both got the antibodies. I feel comfortable. Are you?
I do.
Let's take these off because they can hear us better and we don't want to deprive them of this, right?
Of course not.
Okay. All right. So what we're going to talk about is we're going to talk about the raw water cooling system and what it does on a modern diesel engine. Where's it start and where's it end, Brian?
Right. So simply, cooling system's not black magic. You've got water outside of the boat. You need to get that water in the boat as clean as you can reasonably make it. You pump the water through components through the engine, transmission, and then back overboard.
And the whole goal is hopefully to get an equal amount back overboard in a contained environment.
Absolutely.
All right. Well, let's go in the engine room and see how we get that done.
All right.
All right. Come on with me. All right. Come on down. We've got great access to the engine room in this new 85 Hargrave. What a beautiful spot.
Yeah. Yeah.
This is a whole lot better than trying to do it in a 36 Tiara, isn't it?
Absolutely. Really
Yes,
appreciate
indeed.
Hargrave.
Yeah, they're doing a great job for us. We appreciate that. So the first thing that we're going to do is we're going to look at, as Brian mentioned, the water has to come in the boat. Let's see where it comes in. In this particular boat, Brian, what do we got?
Right. Well, we've got a strainer system which is Hargrave specific. It's very nice, but that can vary from boat to boat, builder to builder.
But each manufacturer has to accomplish the same task, and that is
getting water in the boat and filtering it of some manner.
so we have cool, clean water supplied to the engine.
Yes.
Okay. So from there, let's see where it goes.
Right. From there, you'll make your way. So this is our main line coming off the strainer, which goes into your seawater pump. Auxiliary raw water pump, it's also known as. Standard rubber impeller pump, very common throughout the industry. You've got this plate right here. There's a rubber impeller, easy access. You can change it underway. And from this pump, you've got a couple of zincs here, which we'll get into, but then you make your way out and around.
Okay. So when the water comes out of the pump, we're going to stay on this engine because although we've got two engines and it makes it really convenient to be able to see the inboard side, let's take a look on this engine to follow the water flow. So we're going to come out of the raw water pump, and then what happens?
Right, so we're coming up into this pipe right here.
So stop right there. You said we come into a pipe. And what's that pipe made of?
This pipe is brass, bronze.
Okay, so it's a metal pipe.
Yes. metal
So we
pipe.
got raw water going through a metal pipe. What happens there?
Right, so any two dissimilar metals in seawater creates a battery, essentially.
All right. And what does that cause?
Electrolysis.
Okay.
So with electrolysis, we're trying to mitigate the corrosion. So we're in this case, we use a zinc anode, which is our sacrificial metal.
Okay.
It's
Zinc being a softer metal than bronze or brass gives us the ability for the electrolysis to be attracted to that, like metal shavings to a magnet almost.
Yes, exactly.
So any isolated metal component in the cooling system has to be protected either by a zinc anode or it can be in the bonding system so that it would carry that electrical current, the electrolysis, away to maybe a common sacrificial anode.
Right, common to so your strut zinc or your shaft
zinc on the back of the boat.
Zinc on the back of the boat, anything in the water.
Okay, awesome. So we've seen that the water's going to come out of the pump, going to come through a pipe that's going to be protected. Then where's it go?
Right, then we're going in here to the aftercooler.
All right.
So this aftercooler is our seawater air cooling system. It is also known as an intercooler with other manufacturers.
Okay, yeah, older technologies, older school, they called it an intercooler quite a lot. Aftercooler, and the reason we call it an aftercooler is because it's cooling the air after it is compressed in the turbocharger, correct?
Correct.
Okay, and when we compress the air in the turbocharger, what happens to that air?
Compressed air creates heat.
Okay, so we want to remove the heat from that air
Yeah.
because cold air
Cold air makes horsepower.
Cold air is denser with more oxygen.
Mm-hmm.
Okay, so we're going to pull the air from the turbocharger through the aftercooler, cooled by the raw water, and that air enters the engine. So now the air is moved away. Where's the water going to go?
Right, so we keep moving along, and we make our way out, another pipe, zinc protected, into your heat exchanger. This is a plate type heat exchanger.
All right, so the plate type heat exchanger is, although it's not brand new, it's a newer style of heat exchanger than what was used in years past, if I'm not mistaken.
Yeah, the tube and bundle style.
So the old tube and bundles, they were either round or actually on some of the old two-stroke motors that we all are familiar with, it was a big rectangular box.
Yeah.
Okay, and it had a round plate on the side that bundle would come out of.
Right, and those bundles were also made of soft metals just to try and remove as much heat as you could.
Okay.
But obviously there was corrosion issues with those along the way. So that's why these titanium plates type are becoming the standard.
Okay, and
because
tell me a little bit about titanium, because titanium is a space age metal. It's an expensive metal too.
In theory, but it's actually pretty common.
Okay.
And it's highly corrosion resistant.
Okay.
And it's
important in a saltwater environment.
Absolutely. And it also rejects heat very well.
Okay.
So it's great to use in this system where you've basically got these plates here where seawater is going one direction, cooling's going the other, and it's pulling the heat out of that coolant as it goes by.
Okay. So in this particular application, if I'm not mistaken, it's a dual purpose cooler, because it's not only cooling cooling the engine water, but it's also cooling the fuel.
Correct. Yeah, we've got our fuel lines here, whereas part of these plates here will cool the fuel.
Okay. So this is a great opportunity because the folks at Pantropic have been generous enough to invite Heather over to the shop, and Raphael has 2 heat exchangers on the bench over at the shop, completely disassembled. One of them has been cleaned, the other one has not yet been cleaned. So it gives us a unique opportunity to have a look at what happens to a heat exchanger through its service life, and then what do they do about it to return it back to new condition, and why they're using the titanium, because it's such a resilient material. Heather, we're going to give it over to you and let you and Raphael give us an in-depth look at heat exchangers.
Thank you, Paul. I am here at the Pantropic service shop in Fort Lauderdale with Raphael Betts. We are fortunate enough to have the 2 heat exchangers that Paul was talking about. We have one that has been cleaned and one that hasn't been cleaned, so we're going to take a look at it.
Hey Heather, how are you?
Good morning, Raphael.
Look at that. What?
Look at that.
I like it. You doing good? Good to see you again?
Good to see you again, too.
Absolutely.
I remember last year we were cool without the mask. Are you cool without the mask?
I'm good. We're good.
All right.
Excellent.
Let's take them off.
Oh, I can breathe again. I can breathe again.
All right, so show me, what are we looking at here?
Yeah, so we've got 2 heat exchangers, right? And so we were fortunate enough to have one cleaned and one not cleaned. Mm-hmm. These units have roughly 700 hours on them. So we're going to get a good look at kind of what starts to happen and when your service interval starts to come up at about 1,000 hours. So let's start with the dirty one.
Okay.
Okay.
Let's take a look.
So just a couple key pieces here. So this is the front plate here.
Okay.
Okay. And so that goes on the front mount. This is the rear frame. And then these are all the plates that go in between. Okay. These plates are made out of titanium. Titanium is a really good conductor of heat in the sense that it gets hot fast and it cools fast. So it works really, really well that way. And it also is extremely corrosive resistant. Okay.
Gotcha.
In its conductivity, it's about 1/4 better conductor than iron and about 1/23 better than copper.
Wow.
So when you kind of get a little reference point there, right? And in the corrosive scale, on a 1 to 12, it's floating between 11 and 12, depending on what grade of titanium that you use. So it's really, really good product. It's expensive. It's considered a rare metal, right? It's a precious metal. But it's expensive, but it lasts a really long time, and they're extremely durable. And it allows Caterpillar to design these in a very thin manner so that you can use them quite a bit. So you can see they're almost paper thin.
Yeah.
And they seem a little wobbly, but they're very, very durable when you stack them and then you compress them.
Okay.
Okay.
So these come in a stack like this?
Yep, and they'll vary.
Then they just compress?
Yep,
okay.
and they'll vary in size, right? Depending on the requirement and the cooling capacity of the engine. They'll vary in size. You'll have some that stacks are a little bit shorter, and you'll have some, this is one of the larger ones.
Okay.
So on higher horsepower engines, you'll see a little bit bigger stack, okay?
Okay.
And so then you have gaskets in between, and you also have these little O-ring pucks that go in there.
Ooh.
Yeah, there's a little grime in there, right? So like I said, this one's got roughly 700-800 hours on it. And so you can see that you start to see some of the corrosion happening that we'll show you very specifically in a second. but you also see some of the sediment and stuff that can get into the heat exchanger, right? So
Right.
this is why sea strainers are so important. But you'll start to see some growth, okay?
Sure.
You see little things coming in there. You start to see a little bit of growth in there.
Mm-hmm.
And then if you get into the stack a little bit, you can kind of see how dirty it can get.
Oh, so what is all that?
So it's just growth. It's,
Okay.
you know, there's microorganisms in the seawater.
Right.
I think we talked about that last time.
I think so.
But so those microorganisms will go find a nice warm home.
Mm-hmm.
And when the engine's not running, they'll just plant themselves and they'll start to grow. And so you can see some coolant here, which, you know, you got coolant, seawater flowing through here. And in this particular stack, you also have a fuel cooler. And so that usually uses about 5 plates.
Okay.
Okay. And so that works that way. Let me clean my hands here real quick.
Sure.
And so this is the rear frame. And so this is where your seawater inlet that Paul and Brian spoke about earlier. And you got your seawater coming in and then your seawater goes out. So it comes in this pipe here. You got a zinc anode here, right?
Okay.
Okay. So let's show you what happens after about 700 hours. You
Let's
ready?
see. I'm ready.
So
Oh.
that zinc's not pretty anymore.
That is
so it
not
starts
pretty.
to corrode. And so what happens is that this now doesn't work anymore. So people will look at this and say, oh, it's still there, it's working. At this point, it's time to change it.
Yeah.
You know?
It looks like it's time for a new one.
Yep. And so what happens is this elbow starts to get very similar corrosion.
I see.
So you can see all the pitting starting to happen, the flaking, right? See if we can get this ring out without too much trouble. Too much trouble.
Too
So
much
that ring
trouble,
comes
that's
out, you're
all
going
right.
to see a little bit more of that. And so ultimately, this elbow is not in horrible shape,
Okay.
and it can be cleaned and can be set back into a good position. But for the most part, you want to avoid that. Okay.
Okay.
And then you'll see in here, you can start to see some of the corrosion that comes in here. You get some calcium buildup, and you can see it around the rings. So all this gets cleaned in the process. When we take these apart, this will all get cleaned and polished again. Make sure the surfaces are flat and they'll be able to seal properly.
Mm-hmm.
Okay. And so that happens there. So that's what it looks like at about 700 hours.
Okay. Now, is
Okay.
this one that has been properly taken care of, or is this just what happens?
Yeah, this is pretty normal. This is
Okay.
a vessel that has good maintenance practices. This is pretty normal for about this time of period of time, sorry.
Okay.
And you know, look, we live in a harsh environment. We're in
Sure.
South Florida. It's hot, it's humid. So all of these things create conductors, and those conductors expound all these problems that we have on these heat exchangers.
Mm-hmm.
So it's very, very important to do that, you know? So
Okay.
maintenance, maintenance, maintenance. We preach it all the time, right?
Absolutely.
So let's look at one that looks pretty clean. So this one's been serviced,
Okay.
and you can see that the surface, you can kind of see a little bit of the wear. That's from
Yeah.
cavitation from the plates and the seawater
Okay.
going through there. But you can see how polished it is.
Yes.
Looks a lot different, right?
A lot better than the other one.
Yep. And so now we're looking at these plates, and big difference.
Oh,
Really
yeah.
clean now.
They look good as new.
Yeah, they do. They clean up really, really well. So titanium organically creates this oxide film, and that's what keeps the corrosiveness down. That's what's its real protector. And it does it naturally. So it's not something that has to be chemically created. So there's no room for error, for example, right? And so it does that with the stack. Gaskets, very important. If you maintain your heat exchangers and you do it properly, you stay on schedule, you can get 3,000 to 4,000 hours out of these gaskets,
Wow.
which is a long time. That is more than the useful life for most owners, right? If you don't, you can expect a hefty, hefty cost of replacement because these gaskets will swell. They won't sit properly anymore. You won't be able to seal the stack. The stack is sealed through compression, and it's set. So these gaskets, when you buy them brand new, they're 0.4 millimeters in thickness. As you compress
wow.
them over time, they'll reduce their thickness, right? Just like anything else.
Sure.
And so when you can't get that 0.4 millimeters, you can't compress the stack properly, and you'll start to leak.
So then
So-
you will need to replace all of them.
Yeah, because for you to
Okay.
go through and measure every single one and find the 3 that are bad, it's not going to be worth it. Because what's going to happen is you might find the 3 or 6 or 10 that are bad, but very shortly after that, you're going to have another 3 or
rest
6
of
or
them.
10 that are going to go bad. And so then
Gotcha.
you're going to have a leak, and then that's not good customer service. So,
Right.
you know, so we want to maintain maintenance. You want to stay on your intervals. You want to stay on your schedule because that's what keeps these costs down in your maintenance costs.
Absolutely. Now, speaking of cost, what is the average cost for this kind of cleaning service?
So the average cost for something like this is right around $1,200 to $1,500. So
Okay.
that's removal, that's cleaning, that's pressure testing, that's inspections, and then reinstallation.
Okay. And then about how often again?
1,000 hours.
Okay.
Yep, you
So
wanna
in
do
the
it
grand
1,000
scheme
hours.
of things, I mean, that's pretty worth it instead of having to replace an
Absolutely.
entire...
I mean, we always talk about it, right? You got a $15 million investment, right? In we'll call it a toy, but in your pleasure, you have a $15 million investment, and you're only talking about spending $2,500 every 1,000 hours to make sure that you can enjoy your investment.
Absolutely.
Yeah, absolutely. So, any other questions?
I think that's it. Thank you very much, Raphael.
Awesome.
And you heard it from him. Get it before it's too late and keep up on your maintenance.
Absolutely. Thanks
So,
again.
Thank
So we'll
you,
shoot it back to
Raphael.
those guys.
Yeah, back to you, Paul.
Heather, I got to tell you, we now know more about plate style heat exchangers than we ever thought we needed to. But that's really interesting and really fascinating how it works, why they use the materials they do, and how Raphael is able to basically make it new again after it's been in use. So we're going to continue along in our discussion of the raw water system, and the water is now going to exit the heat exchanger. We're going to go to Brian and find out where it goes. Brian?
Right? Hey, so the heat exchanger, we moved over to this engine. We're coming off of here, same, this hose to this main coolant pipe or seawater pipe. We're heading aft. We're going to get to this splitter here. So this is basically where the engine stops and the boat takes over. Hargrave's done a great job here of splitting and plumbing this in place. Nice valves. You can see everything's bonded like it should be. Pressure valves. It's a great installation. But so our water's split in half here. Half is going this way, which goes to your transmission cooler, in and out of the cooler, and then it joins this main line again and just heads up to your, follows up here and goes into your exhaust elbow, which you can see is also bonded. Pressure gauges, so you can, if you get a restriction here, you can see it, which would tell you that there might be a restriction, which could be as far back as the transmission cooler, which often gets overlooked, or forward up to heat exchanger, aftercooler. Pump, your pump impeller blades may be starting to get old. They get a little memory to them. They don't pump quite as much as they used to. That's having something like that on the end of the system that you can monitor is a huge help.
So that goes back to our original discussion that we want to have equal amounts of water coming in and going out through our controlled environment.
Yeah.
So some of what we've talked about here, Brian, we've kind of taken for granted. One of the things that I'd like to highlight is the way Hargrave installed the pressure gauges in here. What a phenomenal diagnostic tool that is. If you don't know what you're looking at, then why would you put that gauge there? But knowing what you're looking at, what is it that you're trying to determine there?
Right, so if you've got, well, when everything's brand new, clean,
Right?
you can see where your restrictions are going to be in the system, and you kind of make note of that.
Okay. Or
And,
maybe even put an indicator on the gauge,
Right.
so that it's easy to tell if the pressure's
Sure.
increased or
Yeah, if
decreased.
you've got a couple of engineers, you can put a little tape mark on it, sure. And then you've got a baseline to move off of.
Okay.
So down the road, as this transmission cooler gets dirty or your heat exchanger gets growth on it, or the impeller, whatever, you'll see this here, that pressure change.
It'll
go
start
up.
to
The
fluctuate
restriction's
and
gonna go up.
increase.
Yeah.
Okay. So there are a couple of different things that we're talking about here. One of which is, it's not that you're doing anything wrong if that pressure starts to increase a little bit. That's just natural in the service life of the cooling system. And that's why we have to go into it on regular intervals, disassemble components, clean them properly, and return them to service in a new fashion so that we're keeping that heat down. So speaking of heat, what's going on in modern engines today? What we used to do is we used to look for 165 to 180 degrees of freshwater cooling temperature in our engine. We knew things were okay.
Right.
Well, today I look at a Caterpillar heating gauge and it's 210 degrees.
Yeah.
What's going on?
With emissions changes over the last 20 years,
Okay.
in an effort to clean up, we run the engines warmer.
Okay.
It burns off more particulate.
Okay.
So essentially, with the increased emissions, we're building horsepower along the way, but we're running warmer.
So the engineers have determined through their studies that the increased horsepower coming from these engines obviously is creating more heat, but it's better for emission standards to be able to run that engine hotter. As you said, it burns off more particulate. Now, if I recall correctly from high school chemistry, water boils at 212 degrees. So if we've got water in the engine and it's running at 210 degrees, that's 2 degrees away from a critical point. What are we doing in there to increase that boiling point so that we can run this engine hotter?
Right. Well, it's a pressurized system.
So there's a start. Another thing that we learned in chemistry class is that your boiling point increases if you pressurize the fluid that you're boiling.
Correct.
Okay, and what else can we do?
And the coolant that we use has got glycol. Glycol raises that level as well.
Okay, and the glycol not only raises that coolant temperature or cooling temperature, but also there are corrosion inhibitors in that coolant additive as well, aren't there?
Absolutely. Yeah.
Okay,
Yeah.
so that's on the freshwater side, which is a discussion that we'll have another day.
That's it.
Excellent. So what we've got is we've got raw water coming into the engine. We've got it going through the after pump to the aftercooler, from the aftercooler to the heat exchanger, which does a dual duty, and this one is a heat exchanger and a fuel cooler. It comes out of the heat exchanger and fuel cooler, and it goes back through the piping, and it goes to the transmission cooler, and then from the transmission cooler, it goes up into, well, there's also an oil cooler in that system that we didn't point out directly, but again, we're cooling engine oil, right?
Right. And in this case, it's used coolant, so it's out of that raw water loop.
Okay, so in this case, it's a freshwater oil cooler. All right, so that's not a part of our raw water discussion on this engine. But after it comes down through the transmission cooler, then it goes to the exhaust system in the shower head where the water sprays and cools the air as it exits the boat, the exhaust air.
Cooling the exhaust. So you can pump it overboard through fiberglass piping.
Okay, and it won't damage the fiberglass because it's not as resistant to heat as these high temperature elbows are.
Correct.
Coming off the turbines.
Yeah, it's nothing to it, right?
It's simple. I thought it was black magic.
I know, yeah.
Not
We're
at
in,
all.
move it along, get it out.
Get it in, get it out. Okay. All right. I think we've got a good handle on our cooling system from start to finish. I think everybody has a great understanding. Again, I want to thank Heather and Raphael from over in the shop, giving us a really great idea of how the heat exchanger works and the materials of the heat exchanger and how to clean it. Last year we talked about the aftercooler. This year we talked about the heat exchanger. Maybe next year we'll figure something else out downstream and talk about that. Thanks, Brian, so much for everything. I really appreciate the great explanation and your hospitality here. Thanks to the folks at Hargrave for doing a beautiful job of helping us aboard. And we're going to cut in a moment here and move to our next segment. We'll be back after a commercial break. Thanks for joining us.
Yacht Engineering Week 2021 has been made possible by Pantropic Power, the only authorized Caterpillar Power Systems dealer in South Florida. Florida Nautical Surveyors, your complete solution to all of your vessel surveying needs. And Robert Allen Law, exclusively dealing with the business of yachting. We would also like to thank Quantum Stabilizers, AME Solutions, DeAngelo Exhaust, MPI Marine Professionals Incorporated, Concord Marine Electronics, Lauderdale Marine Center, Marine Data, Isotropic, Dockmate, and Murray Ventilation Products. Thank you for joining us this year. We'll see you in 2022.